I'm gonna give you your next lesson here. Hopefully, I'm in tomorrow. Things went well yesterday, just a little pain today, but I want to give you this lesson so you can just make sure we're staying on pace with where we need to be. So, what you're gonna see on this video right now is a graph that I made ahead of time. So you don't have this on your paper, but you can draw this in. I'm going to explain how we get this graph just because it's a little bit of work. But what we're doing today is we're trying to find the area. So like our goal is to find the area in this region, like right here. All right, that's bounded by these two curves. And what I taught you last week was that if you, and obviously it goes here too, it's just I want to make it a little thinner. Let's see if I could do that. Color this in. So there we go. This area that's here, bounded by the two curves, you could definitely, go back and try our methods that we used last week, and everything was done with respect to x. But the problem with this one is when you look at this function right here, it's given to you as y squared is equal to, and you can certainly take the square root of both sides and graph it as, plus or minus the square root of 2x plus 6, but then you're graphing two separate arcs here would be the positive radical 2x plus 6, and this would be the negative radical 2x plus 6. But we don't want to be using two different functions, so another option we have is to do everything with respect to y. So that's what the lesson is today. We're going to be using the integral with y in it, and we're going to be using y limits. So when you're finding your limit values for your integral, we're using y values and not x. So let me show you how we get this. First of all, I graphed this function on a program called Desmos, which I think I may have used this with you a few times. I know I have in Calc 1. If you can even go on your phone and find this. It's a really nice, you can go to the website, there's even a Desmos app. It's a great app for your phone. And you could actually plug any function in any format. It could be y squared is equal to, it could be all in terms of y, and it'll graph it. So this right here is what you get. Now if this were a test or quiz, and you wanted to graph this, what you would have to do is kind of do what I mentioned to you before, and that is take this function right here and graph it as y equals the square root of 2x plus 6, and then in y2 put y equals negative square root of 2x plus 6, and it'll give you both versions, but then know that when we go to integrate, we're going to use it in terms of y, and actually what we're going to do is subtract this 6 over and divide by 2. That's how we're going to get our limits and everything. So let me go to the problem, but this is what the graph looks like. You can put it on your paper, and you'll see that it's basically what I have here. And remember, once we try to figure out what's going on here, you always are doing top minus bottom. So let's go back to the formula, and I'm going to do my best to write all this stuff out for you. Sometimes it's not as easy to do on this, but the shaded region is equal to the integral from a to b of top minus bottom. And then, of course, depending on what variable you're taking this with respect to, this is either going to be dx or it could be dy. This, right here just depends on, are we doing it with respect to x or y? Here we're going to actually do it with respect to y. If you look at the graph we have, so let me show you something really quick. I'm going to just do this and show you something a little neat here. But here is our graph, right? I'm just going to paste it over here. And if we were to rotate this, all right, you would see that the top function is the linear function. The bottom function is the parabola. So really, when you're dealing with respect to y, because again, we're going to integrate this with respect to the y-axis, it's actually right minus left. So either top minus bottom if you're doing with respect to the x-axis, the top function minus the bottom function, or if you're doing with respect to the y-axis, it's right minus left, which you can see here when we rotate it, it's still top minus bottom, but the top function is the linear. Back in our original graph here, you could see the linear is on the right. So that's just a little something to show you there. Okay, couple things we need to do before we set this up, since we are going to do top, which is the linear, in terms of y. So we're going to have to add this one over, minus the bottom, which is the parabola, which is almost in terms of y. We got to subtract 6 and divide by 2. We're going to have to figure out what the limits are. So let me write this out. We have s is equal to, we'll do our limits in a minute. Now, we need this function in terms of y. So we're just going to add the 1 to the other side and get y plus 1 minus, right? Because, I mean, I could write it out for you, right? You'd get y plus 1 is equal to x. I'm trying this out with this pen here. It takes a little bit. So y plus 1. And then the other function, here I would subtract 6, divide everything by 2. So you'd have, you guys are smart enough for me just to do y squared over 2. And then minus 3, right? We subtract 6, divide by 2. Okay, and this would be dy. Now, talking about limits, we're going to take these two functions and set them equal to each other. So you have y plus 1 equals y squared over 2 minus 3. At this point, I would just multiply everything by 2. And if we all do this in our heads, which I know we can do this, to save me some writing, multiply everything by 2, subtract this stuff over, here's what you get. This will become 2y, this will become a 2. So we have y squared, right? No 2 on the bottom anymore, multiplying everything by 2. This 2y is being subtracted over. And then this is now going to be a minus 6, but I'm also subtracting 2 more. So if I subtract 2 more from a minus 6, I get a minus 8. And again, just to save me some painful pen strokes here with the mouse, if we factor t-bar this, you're going to get minus 4 plus 2, which is 4, and negative 2. Which is exactly where this is right here. This is at negative 2 for the y. And this is at 4. We're talking y values, remember. 4, negative 2. Okay, so we have negative 2 and 4. All right, so simplifying this, you end up with y plus 4, right? Oh, sorry, that's not right. No, it's right. Negative 3 times negative 1 is 3. 3 plus 1 is 4. And then this is just y squared over 2. So I'll just put it as a negative y squared over 2. And then plus y. There we go. Make this negative a little bit bigger. And then 1 minus a negative 3 is 4. Ugh, get rid of that. That's terrible. I could do better than that. All right, hold on. I still think that's better. Don't make fun of me. Okay. If we integrate this, then s is equal to, we raise it up by one exponent, divide by the new exponent. So we have negative, come on. Okay, this mouse is starting to not like me. All right, negative y cubed over 6. Jeez, come on. Half of you are probably done with the problem already. And then plus y squared. How about that weather out there, guys? Is it snowing? How many of you just answered me out loud even though I can't hear you? All right, cool. And then plus 4y. And we're doing all of this from -2 to 4. Okay, of course the good thing is you can still do this in your calculator. So if you went to your calculator, hit second 7, I believe it is. I don't know, I can't think of it right now. And then did everything with y variable, and then comma y, comma -2, 4, you'll still get the right answer. So I would recommend you go and do that and just double check this. But let's see if I can do some quick math work in my head here. So 4 cubed is 64, so -64/6, which is the same thing as -32/3. Plus 8 plus 16 minus, and if we put -2 in, we get -8 negated, right? Which will give you +8 6, which is 4/3, and then plus -2 squared over 2, which is 4, over 2, which is 2, and then 4 times -2 is -8. Let's see if I can do the rest of this in my head. So -32/3 minus 4/3 would give you -36/3. And then 24 minus 2 is 22. Minus 8 is 14, right? Let me double check that. 24 minus 2 is 22. Oh, plus 8. My B. Distribute, sir. All right, so we've got, how about I just do it this way? 24, and then this is minus 6. It would be plus 18. Okay. No, it's not right, is it? Hold on. It's positive 6. That's not right. Okay, I'll get it, guys. Don't worry. I'll figure it out. All right, how about 24 plus 6, right? 24 and then -2. It's, yeah, -2 plus 8. So plus 6. It's still on the meds. So I'll just blame it on the meds. I think that's I think that's right. Oh man. All right. That's right. Okay, and then we're gonna multiply everything here by 3. So we've got 90 minus 36, and that is 54 thirds, I believe. Right? And 90 minus 30 is 60, minus 6 more is 54 thirds. This is so painful, isn't it? Probably having a great time laughing at me. I see Kyle's probably laughing at me. Jay's getting a big kick out of it. All right. And of course, 54 is divisible by 3. You end up with 18. So, should have got 18. I hope you got 18. I don't have my graphing calculator here, but hopefully that's it. If I made a mistake, correct each other, but I'm pretty sure that was it. So all of this is with respect to y. And notice that we had to change our limits, or at least find our limits in terms of y, substitute it all in, and there you go. So if you look at question 2, the nice thing is here I gave you the graphs for these, and I put them in, well, at least the first one is in x equals form. You're going to have to solve this one for x equals. And then set them equal to each other, find your y limits. So we're looking for what y value is this, what y value is this. No, not that. What y value is this. Okay, so we want our y values for those 2 points, and that's how you'll get your limits, and it's top minus bottom. Just scrolling down here, because I'm not going to do this whole video. You can see here we have 2 parabolas in number 3. the blue one and the red one. A little hint here, you can see that this 4 is right here, and you can see the 4 right here, so that's going to be the blue function, and the red function is this one here. It has a y-intercept, or an x-intercept, I should say, of 0. Down here, this one's a little interesting. I'm just going to show you something real quick with it. The curve e to the x, or e to the y, I'm sorry, is right here, the red one. You can see on mine. And this is the parabola. It's being bounded by the lines y equals 1. So let me just do this. Y equals 1 would be here. So you just to add this into your graph. All right. And then, let's see. Can I make it bigger? Yeah, we'll go like that. And then we'll do, the other one is y equals -1. So let me just copy and paste that. Y equals -1. So what we're looking at is this right here. All right, we're looking at this whole region. Whoops, I went a little too far. Do that again. We're looking at this region right here, bounded by just this stuff right in here. And again, if you wanted to do it with respect to x, you can. It's just way more complicated. So we're going to use y here. You're going to have to set these two things equal to each other. Now, when you set these two things equal to each other and you try to solve for y, that's a little tough, right? So, when you're trying to get your limits, you would think, well, if I set those two functions equal to each other, they really don't even intersect. Think about it. Setting this function right here equal to this function is going to give you the intersection points down here. Let me circle it in red here. It'll give you this intersection point, and then wherever these things may intersect up here, and it looks like they don't, that's not what our y limits are. Our y limits are bounded by these two lines right here. So the great thing here is you have 1 and -1 as your upper and lower bound, because that's where the two functions are trapped in between. So that one's easy. You don't have to actually show any solving for limits. All right, give these a shot. I should be back tomorrow, and we'll go through the rest. I'll just go over the answers with you really quick. And then we have just a couple other things to do in this section. We're actually doing fine on time. I'm not really concerned, but had I not shown you this lesson, there you go. And by the way, on my desk I have my snow day blue sign. Somebody go touch it. All right, wish us luck. Maybe tomorrow we'll get a snow day. Gotta give it some luck. I'm praying for one. I could take an extra day of rest. I think that would be nice, but I'm coming in even if I'm not feeling too well tomorrow. So we will see you guys. Good luck with this. If you have any questions, help each other out. You could also send me an email or something. But I think you are in good shape. All right, guys. We'll talk to you later.